సరే సార్. అవునవును సార్, అవును సార్, అవును సార్.
So start moving.
అవునా కెమెరా లేకున్నా ఇది కెమెరా మైక్ కూడా
Yes, by phone.
वो स्पीकर ऑन On है पकड़ दिया।
Respected head of National Management Authority, Shri Krishna, personally, Distinguished Secretary, Minister of Sciences, Dr. Ravichandran, respected Director-General of the India Meteorological Department, Dr. Mohapatra, esteemed Chief Speaker, Professor Sagnik Dey, distinguished scientists, and my colleagues. Today we are here for celebrating World Meteorological Day
मीटिंग में तो जैसे
2026 with the theme observing today and protecting tomorrow. And this is, we are celebrating as the establishment of the WMO, the UN agency, and plays a crucial role in weather, climate, and water-related activities. So now I request Indians are kindly participate on the chief guest. Sir. And our chief speaker, Philip Lau, the main story. Thank you very much, sir. So now, actually, there are really people to meet. Today we have with us our chief guest. As he has a leadership and played a very crucial role in shaping India's disaster preparedness and resilience strategies. We are very thankful to you, sir. And we also extend our secretary to our Secretary Minister of Sciences for the guiding force and coordinating new initiatives and operational infrastructure activities related to space weather forecasting, ocean services, and climate research. We are equally honored in the present by the President of our India Meteorological Department, who support and all-time guidance an important role in shaping of weather forecasting and planning systems. We are very thankful by overall delegates this year and the dignitaries that are coming here for with us and we celebrate this occasion. Also, we are really welcome Prof. Secretary, whose distinguished contributions and guidance in the field of atmospheric science and air quality research. Now, I again extend my warm welcome to all distinguished scientists, officers, our colleagues for this occasion of the World Meteorological Day. Thank you very much. I will calculate and will be in session.
जायते वृष्टि आदित्य जायते वृष्टि
मौसम विभाग वंदे मौसम विभाग वंदे हम हर मौसम पढ़ने वाले मानव जीवन के रखवाले वसुधा परिवार हमारा है मौसम विज्ञान सहारा है
पृथ्वी की गतियों का विधान ऋतुओं का शाश्वत संविधान।
जलवायु और पर्यावरण के परिवर्तन का ध्यान,
आपदाओं से हो सतर्क सब IMD अभियान।
ये मौसम ज्ञान पुरातन नवल विज्ञान प्रभावन।
जल थल अंबर हर गांव नगर पर्वत घाटी जंगल सागर, जीते हम संग फिजाओं के, लाते संदेश हवाओं के।
सहयोगी मित्र किसानों के, जन जीवन की मुस्कानों के, कर्तव्य निष्ठ मौसम प्रहरी, जन सेवा में आस्था गहरी।
करते अध्ययन तूफानों के, नव चक्रवात अनुमानों के।
जन धन जीवन रहे सुरक्षित, मंथन अनुसंधान, मानवता के लिए समर्पित मौसम का विज्ञान, मानसून संज्ञान।
अपना ज्ञान पुरातन अमर वर्णान सुहावन।
वैदिक संस्कृति का नव विहान, ऋषि चाणक्य का अर्थ ज्ञान, कवि कालिदास के मेघदूत, आदित्य प्रभा के अग्रदूत।
मौसम उपग्रह का दिग्दर्शन, ऋतु चक्र प्रवर्तन विश्लेषण।
भारत के स्वर्णिम कल के लिए शुचि मन में दृढ़ संकल्प लिए।
साक्षी समृद्ध विरासत के, हम गौरव प्यारे भारत के।
पूर्व पश्चिम उत्तर दक्षिण शुभ कर्म योग संधान, सीमाओं के पार हमारी करुणा की पहचान, सहयोगी गुणगान।
मौसम ज्ञान पुरातन अमर विज्ञान पुरातन। मौसम विभाग वंदे, मौसम विभाग वंदे, मौसम विभाग वंदे, मौसम विभाग वंदे।
Namaskar, good evening to all of you. Respected guest of this evening, Shri Krishna, member and mayor, that's from the Master Authority, respected Secretary, Mr. Prof, Secretary, distinguished speaker of this evening, Professor Sagnik Dey, Head of Center of Practical Science, Indian Institute of Technology, Delhi. Our distinguished friend, Head of DINAM, distinguished friends from various institutes, Minister of Arts Sciences, sister organizations, and colleagues from India Meteorological Department. Distinguished friends and colleagues, those who have joined online on this festive occasion. At the outset, I extend my heartiest greetings on behalf of India Meteorological Department and Meteorological Fraternity on the auspicious occasion of World Meteorological Day 2026. This year, the World Meteorological Day is being celebrated with the theme of observing today, protecting tomorrow. As the theme suggests, the observation is key success in protecting our lives and properties. Not only that, the observations also helps in optimizing our weather and climate information, in improving our socioeconomic progress. Climate is nothing new. We know from the very beginning that science of meteorology started with observations, with the invention of Galileo's thermometer, then barometer, ionometer, such basic instrumentation. Thereafter, we came up with the satellite data, in between the radar data, Now, of course, we have got various types of sophisticated instruments like civil profiler, microradiometer, designed and designed instruments for specific sectors like aviation instruments, or the instruments for the water sector, instruments for agriculture, instruments for marine sciences. So now the instruments are many, and also the observations have increased many more. At any time, you will find that there is about 60,000 observations, conventional observations, being taken globally. And if you look at the satellite observations, you know, at a glance, if you just look at about 500 GB or so data are being generated by the various geostationary, polar orbiting, and LEO satellites. So all these observations help us in understanding the current situation, analyzing the various weather systems, and also based on the past history of such weather systems, we can predict what is going to happen. Long way, this was understood, consider the fact that weather science is a nonlinear science. So here you cannot solve the mathematical equations directly. You can solve it nonlinear and hence the numerical weather predictions. When you go for numerical analysis or numerical mathematics, so they have the basic observation, the initial condition, the initial status. If you remember when you do x, if x equal to x0 known, then x equal to x1 you can calculate. So that basic principle is applied here also. So therefore, the observation is the first and foremost in a science which is nonlinear. Then we say that weather forecasting is an initial methodology. If your initial value, then the observation is correct, then you can go for predicting the weather. And once you predict better, then you can protect better. So by that way, it is linking three situations. One is the observations, second one is the modeling, and third is the forecasting. But at the same time, when you say protecting, that means it is linking with impact-based forecast and risk-based warning. And today, worldwide, everybody is trying to provide impact-based forecast and risk-based warning in a very granular manner, utilizing the technologies like gas, etc., and with the dense qualitative and quantitative observations. So that is the motto why we have taken up this year, this observing today and protecting tomorrow, to popularize this attitude among the public and to prepare ourselves for the future. And the future is such that where you have to take into consideration the impact of the climate change, which has resulted in more hyperlocal and severe events. And if you want to predict such hyperlocal severe events, you need hyperlocal observations. So therefore, all are linked in a value chain where first observation data goes to the analysis, then analysis goes to modeling, and from modeling it goes to forecasting and sector applications, then goes to early warning, then warning presentations and disseminations, finally anything but forecasting and risk-based warning. So therefore, on this particular day, we can analyze ourselves how much we have achieved towards this direction and how further we can do in the coming years. Certainly, as far as India is concerned, we are in a better position compared to many countries when we consider the early warning. And we have been the peer advisor to provide the support to observation, modeling, forecasting to high countries. Then the region was 30 countries selected for establishing the systematic observation financing facility so that we can upgrade and enhance the observation network, and hence we can improve the forecasting system. At the same time, we don't go for the different types of modeling system. I have come up with the AI model. The AI model is completely dependent on the observations. So you can ensure that good observations, you can ensure that good archived observational data, you can go for reanalysis and redefine the type of data. That will also help in improving the data. But at the same time, I want to say that with the active leadership of our Secretary, Mr. Prof. and Secretary Ravichandran, we have taken a quantum jump. With the declaration of the Prime Minister, we have taken up the mission also. At the same time, we have taken up the AML modeling and other physical modeling. And on corporate systems are being utilized to predict. At the same time, we also came up with a multi-hazard early warning system and a decision support system with indigenous inbuilt within IMP using of the sister organizations like Minister of Organizations. And also, I'm happy to say that our colleagues in Indian Navy and Indian Air Force are also cooperating with us in providing the observations. And these observations are very available. But still, there are many other observations which are not available at present in the forecasting system. If that are available again, I am sure that we will get a powerhouse of observations and the observation not only in India, but also the entire globe in including for the weather forecast and warning services, and hence providing the safety and security to the society and the individual. So, as all of us know that early warning is successful when there is an early action. With the able leadership of our head and member and the staff, we have come up a long way with these knowledge, experience, and expertise. Is tuned NDMA towards a direction where each and every single event is being targeted, be it the lightning or be it thunderstorm or a heat wave or a cyclones or heavy rainfall. So it is now systematically targeted in specific projects are being taken up with a vision. I am sure with your leadership will certainly meet with the active early actions following the early warning, and hence the impact of forecast warning will be certainly the most efficient. It will be an example for other countries. Professor Sagnik Dey has been associated with us, all of us know that, and he is an expert in his own field, especially in the field of meteorology, air quality, or fog, or any kind of similar events. So he has been always supportive, and he has been guiding the people from IMD and other organizations also. So it is really opportunity for all of us to listen to Professor Sagnik Dey on these WMO. So without taking much time, I thank our Secretary, Minister of Earth Sciences, and member of NDMA and Professor Sagnik Dey for providing their valuable time to be with us and inspire us with respect to theme to take the weather and climate services in the region to the next heights. I also congratulate and thank all the participants for their active goals, and I will assure that they will continue to do so to enrich the weather and climate observation from various sources. In addition to citizen science concept, the crowd science we have introduced, the crowd service data also we are collecting, but there is very less. So there is scope here for many type of unconventional data which can be considered for integrating in the system and hence to improve the forecast, what is sufficient, and hence the reduction of the disasters. So thank you very much. Thank you very much, sir, for highlighting and bringing the theme of the day and for various aspects. Now I request sir. Very good afternoon to all of you. Dr. Shri Krishna, sir, member and head NDMA, and also Professor Sagnik Dey, head of the Department of CA Science, Delhi, and our friend Director Dina from Mohapatra, and Dr. Mohapatra, Director-General of Meteorology, and colleagues from Ministry of Health Sciences, IMD, and other organizations. Very good afternoon to all of you, and also wish you all a happy meteorological day. As Dr. Mohapatra mentioned, today's theme is observing today and protecting tomorrow. I think it is very important theme as how the situation is concerned, because the observation is very fundamental to many. I mean, observation means it is like basic ingredients of if you want to have a food, you want to have various ingredients, rice or vegetables or everything. So different kinds of ingredients are required. Here also we need different ingredients of observations, either it is in situ or remote sensing or various observations we need to have it. Once if you have more ingredients, more and more these things. Either you take it institute observations starting from AWS, rain cages, various what is called radius foundation and other observations apart from remote sensing like not only satellite but also radar. So all these observations is very imperative in order to two purposes. One is to understand the processes, and other one is to assimilate into the model so that initial value problem, so the initial condition to be placed. I think hence the observation is very, very important. Many of you know that it is not Indian Meteorological Department has come later. Initially, it started with Indian Meteorological Observatories. So that is what the importance of this observation. One Director-General of Meteorology is the observer. I think started and slowly it is changed. Of course, observations, when you are talking about various kinds, I think the mission motion is an important thing which we are going to, what is called quantum leap in coming years. We start with the radars and we want to have a very place our country to be in the radar visibility, as well as we want to augment the profilers and also with the radiometers so that we can have a vertical profiles of basic information like humidity, temperature, and things. These three are available so that we can have a better information about various parameters so that we can have a predictive value. And also we need to go for satellites, so which we are aiming for next year. Maybe the fourth generation INSAT series, we need to go for it because without that it is difficult. Maybe you take it lighting or any other parameter we need to go, but that's only in Indian Ocean, the footprint of fourth generation is less. Whereas in other places, the fourth generation is in operation. So it is very imperative that we need to go for fourth generation. Also, we need to go for a longer term, more and more observations, not only in the land but also in the ocean. In the ocean, there are many things, argo, utilities, gliders, moon buoy, all these things are available. But I'm sure that the recent years, because of various political constraints, the observations are depleting. So I think it's imperative that we need to augment, for example, persistent prediction and other things. We need to augment more and more observations. So once we have a proper observations, then we always have I always tell that 4 pillars of weather forecast. One is observation, that is a foundation pillar. Then the understanding and analysis, of course, the second pillar. And the third one is a modeling. Of course, modeling now is not only numerical model, but also AI and others which we need to incorporate. And the fourth pillar is, of course, the dissemination and also the impact the forecast so that to protect the not only people but also the planet. I think this all 4 pillars. I think it is now this year's theme is first pillar and the last pillar, so that in between pillar is connected well. And I think it is imperative that we all of my colleagues and requesting all of you, because over the years I am seeing that maybe IMD's 10th earlier it was purely on observation. But I am seeing that over the period, maybe the last 1 decade or 2 decades, the observational components are slowly reduced. I think it is imperative to start back again. So this may be the call for all of us to start the observing things, the importance of observations, as well as the calibration center and validation things. All these things we need to set up in the IMD so that we don't need to go for any calibration, validation for outside. And also we need to motivate the other institutions, especially national lab and academia, the instruments within the country, and also not only conventional instruments, but also now technological revolution is happening. We need to think of various kinds of observation, whether it can go for, instead of radio sonding, can we go for drone-based observations so that we can have a multiple observation in a day, so that we can resolve diurnal variability and other things. So all these things we need to, because without taking the diurnal variability, we don't know
I'm sure that will be not able to capture from discussing the extreme things what is happening global and other things. So it is imperative that we need to go for more and more technologically oriented observations. At the same time, conventionally, we need to go for citizen-centric observations. Citizen-centric means anybody can just report whatever the information what they have. All of this information is very valuable. Even last, I think earlier we were thinking somebody from IIT also, whether we can have a IoT-based system, whether it is what is called, suppose entire country wherever the cars are going, if a wiper is going in one speed, so that means it is indirectly it is raining. Okay, so suppose 10 cars or hundreds of cars going with wiper, that means it is raining. And the wiper speed 3 modes at least, slow, medium and fast mode if it is there. That wiper information if it is available, that itself we can inject data. I think some of the small countries, Shri and other people are making use of it. So like that we need to innovate various ways of collecting observations, information, so that we can put into the model, so that we can have a better initial condition, so that we can have a better forecast, impact forecast, so that we can protect the life as well as the perspective. I think with this, once again, I thank especially our guests for coming. And I also request my colleagues to give more importance in the coming year about the observations in the meteorology system. This, thank you. Thank you.
Thank you very much, sir, for actually highlighting the importance and the observations and the gaps. Okay. Now, there is really my sister from the Secretary-General.
Dear members, colleagues, friends, happy World Meteorological Day. There are many UN international days. So why does this one matter? It's because today we celebrate the WMO community and its role in saving lives and serving society. Let's take a closer look. One of the most frequently asked questions is, what's the weather going to be? People take it for granted that we can find the answer on their mobile phones and televisions. Behind each forecast are millions of observations which are processed in a unique international network coordinated by the WMO. WMO Global Observing System underpins decisions worth billions, from aviation routing to flood protection, from energy planning to health management, from crop planting to infrastructure investments. It generates forecasts and early warnings that save many thousands of lives. So I am delighted that the theme of this year's World Meteorological Day is Observing Today, Protecting Tomorrow. Because when we observe today, we don't just predict the weather, we protect tomorrow, tomorrow's people, tomorrow's planet. And that is why the young people of today are so important, because they are the guardians of the future. We need your energy, your innovation, your skills. Colleagues and friends, we live in an era of great technological advances, but we must level the playing field and ensure that nobody is left behind. We must close the gaps in data and observations, and we must remember that artificial intelligence depends on human intelligence. On this World Meteorological Day, I would therefore like to pay tribute to the many thousands of humans in the WMO community. The observers in remote and lonely locations, the meteorologists who release weather balloons twice a day, every day, the hydrologists who monitor rivers at dawn, the forecasters who stay awake through the night, the oceanographers who brave the waves, the engineers who repair stations after a storm, the satellite technicians who maintain our eyes in the sky, the climatologists who help us understand the past and prepare for the future, the computer processors who crunch and share the data. We are more than just weather forecasters. Together, we provide a global public service for the global public good. Together, we are observing today and protecting tomorrow. I thank you all. And once again, I wish you a happy World Meteorological Day.
I request Secretary Vatsa to address the
Respected Secretary, MOES, Dr. Ravichandran, my friends, colleague, Dr. India Vatsa, and the Dr. Sagnik Dey, all the colleagues here, experts, and distinguished scientists. Thank you very much for inviting me and inviting me as the chief guest. We work very closely. We are good partners, and our collaboration grows stronger every day. We benefit from your forecast almost every day, and most of our services are very much dependent upon the kind of foundational service that you provide. So we are deeply grateful to you for the kind of response and support that we get from the IMD on a regular basis. And I'm so pleased to be here. I extend on behalf of the MA, I extend our warmest greetings to you for meteorological service, and may your service may grow stronger and more precise every day. And we wish all the scientists with the IMD the very best. As you know, with the climate change and variability that we are witnessing, we have right of atmospheric hazards. We are still grappling with them. We have not really found a great handle. How do we deal with the lightnings, which are causing large scale deaths? Heat wave has become a very, very serious hazard. Also, the severity of cyclones has increased, and we also have a large number of flash floods and cloudbursts and flash floods in the Himalayan region. So we are dealing with a whole range of hazards in the country. And on several of these issues, we are working through the IMD. We have developed a project on lightning, and there's a very strong early warning component, and IMD actually is working with us very closely. Similarly, forest fires, we are working on the forest fires, and again there is a component of early warning. Almost all the mitigation programs that we are developing and facilitating, IMD is participating as a partner committed to advancing and strengthening the early warning service. There is a sense of urgency about it, because at the national level, the demand for precision is growing. The people are not very happy with very general kind of forecast that we provide. They want the forecast to be more precise, more granular. They want the forecast to be supported by advisories. And therefore, as we have more expectations of us, we definitely need to improve our services, and that could only be done through more dense instrumentation, and that is the direction in which we are moving. Mission Mausam is of course very, very important intervention, but along with the Mission Mausam, there are several other interventions which which would seek to densify the network in the country. And this kind of instrumentation is for not just for rainfall and temperature, this is for all kinds of hazards. As Dr. Mohapatra would know, we are working on the National Himalayan Resilience Mission. We are going to undertake a large program for Uttarakhand, Himachal Pradesh, and Jammu and Kashmir. And we are investing away this instrumentation. So there are a few things that emerge from the kind of work that we are doing. One, of course, is that as we develop the instruments, we need to have a national manufacturing base for all these instruments. We should be able to produce most of these instruments within the country, and we should be able to deploy them at a cheaper cost. Two, it's very important that we conduct the necessary investigations, site-specific investigations for installing instruments, which means that we need to go down to the various remote sites where we can think of the best suitability for these instruments. We also need to think of setting up a network through which we receive the data and we are able to process the data. Calibration of data is a very, very important responsibility. And then we also need to explore the possibility of AI mechanisms through which we can process the data and develop more precise information. I think these are some of the important directions in which we need to move, and I'm sure that the IMD and we working together will achieve it in a very, very short period of time. Nowcasting is becoming extremely important for all the cities, all the districts, and the state governments are also investing quite a bit in this area through their own mitigation funds. So state governments also need this kind of facilities through which they can generate the nowcasting. We also need to think of fact-based forecasting. It's not just the forecast, how it is going to affect the people. So again, this requires more than just the information on the hazards, how the hazards are going to affect the people. So as I see, in the next 5 to 10 years, we will have a large number of very local level weather centers across the country. And we definitely think of people in the remote areas, inaccessible areas, being able to access the data on the weather and temperature and all other related variables. So what we would definitely like to work towards is setting up a large network of the weather stations in the country, through which we can have the local level weather information. So whether local level weather system, whether the local level weather centers are going to be direction of the future. And this is what we need to accomplish. And as we develop more programs, I'm sure it would be the vision for the shared vision for all. So thank you very much. Yeah.
Thank you very much, sir, for giving the insight and various in regards to services and and how to get better. But now, I will request the Sagnik Dey for this section.
Respected Chief Guest, Krishna, member and National Disaster Management Authority, respected Dr. Ravichandran, Secretary, Ministry of Earth Sciences, Dr. Mohapatra, GM IMD, and third Vice President of WMO, my colleagues from IMD and other MOES organizations, those who have joined online and offline. First of all, a very happy World Meteorological Day. It has been an honor and privilege for me to give this World Meteorological Day lecture. You all know that Center for Atmospheric Sciences started its journey in 1979 with the initial funding from IMD, and ever since we share a strong partnership. Personally, I have always been fascinated about how any discipline has evolved over the decades and perhaps centuries, and it became sort of my hobby to collect information, not just for weather and climate, but for any discipline. So what I thought today is that I would start by showing a timeline of the major milestone in meteorology. And when I collected this information, I found that almost all discoveries are because of the observation, particularly in this field. And then I will share some of my thoughts that what I feel is required to become global leader in this particular area. Of course, as mentioned in the IMD in song, that meteorology as a field of knowledge in fact dates back to ancient civilization. And we have enough evidence to suggest that at least people, even in those Indus civilizations and all, started talking about the weather patterns. And in fact, this book is very fascinating to me, where weather science in ancient India is compiled. Of course, then meteorology evolved as a modern discipline sometimes in late 19th century, based on the instruments that were discovered even a couple of centuries before. More systematic measurements, and these are some of the very, very early days where, for example, this is in German, but it basically talks about the storm structure, and then the basic systems. And of course, now we have 150 years of surveys from IMD, which all changes the way we see modern meteorology. In the last century or so, when I started compiling, in the early part of the 20th century, in fact in 1902, you see that the first the Bedouins carried meteorological instrument alone. And these experiments were done by the French scientists. And first time they observed actually that suddenly you have this temperature reversal. And they kept on doing these experiments for several years, because they were not believing that why suddenly temperature will start increasing, and eventually it led to the theory of this layered atmosphere. 1904, again, for the first time when Puritans proposed to establish initial conditions are required for forecasting. 19 is the first meteorological flight to collect data on clouds. And we can see actually from this milestone that how far we have come today. 1919 is the first paper ever published on cyclone structure. 1920 is when Milankovitch proposed the Milankovitch cycle to explain the long-term climate variability. 1925, again a landmark year, first time the thermodynamic diagram concept was proposed by Sir William Napier. So, and also Sir Gilbert Walker in that year discovered the southern oscillation based on observation. 1928, first radiation development, as well as the first ever graduate program in meteorology anywhere in the world under Rossby leadership. Then in the middle few decades of the last century, you see 31 is when Vladimir Köppen publishes his famous climate classification scheme. 1933, when Bergeron proposed his idea of raindrop formation. Then, of course, the World War hit. And in fact, for the World War, there is even renewed interest in understanding the weather. And then 1943 is the first time when radar has been used to track rain shower in India. And then, of course, 1948, again, you can see Eric Clement demonstrated that the minimum SST is required to sustain tropical cyclones. 52 is the year when US Weather Services issued the first ever severe storm. 1957, of course, all of you know that is the International Geophysical Year. Two landmark events happened. The famous carbon dioxide measurements at Mauna Loa Observatory in Hawaii started in that year by Charles Philip, which completely changed our understanding of the climate, as well as the first ever satellite was launched by the Soviets from that year. Then 1963, the classic chaos theory was introduced by Edward Hurd. And then afterwards also you see that there is a new era of observations and modeling because of the advancements of satellites. 1967 Global Atmospheric Research Program begins, and that is the year when Manabe and colleagues created the first climate model, and of course because of this we all know Manabe received the Nobel Prize later on. 1970 again, meteorologist Bryson was the first ever to suggest that atmospheric pollutants can cool the Earth's climate, and now even after 50 years, many of the models have large uncertainty how to deal with aerosols and aerosol cloud interaction. 1975, CMWM was formed. Next year, peak ocean core data provide robust evidence of melancholic cycle. 79, eventually World Climate Research Program begins after the National Academy of Science report on the carbon dioxide impact on the global warming. And then, of course, the world has changed drastically with all the global treaties in Montreal Protocol in 87 and then establishment of IPCC and all of it. Even today, observations are contributing so much. Only last year, this very, very interesting paper came out in Nature, where from the first time, based on cloud observations and looking into the cloud motion vectors, the authors convinced that there is a change in atmospheric circulation which the models and the analysis data show. So of course, we are talking about all of these observations, and you can now see how things have changed over the several decades and perhaps centuries. So with this background, let me share some of my thoughts, what is important, my opinion, and of course already we have taken some of these steps as mentioned by Dr. Mohapatra and Dr. Ravichandran. So today we have a lot of networks. For example, IMD itself is managing the network of the meteorological observation, both at surface and upper air. There are other networks managed by other English institutions. There are also networks managed by ISRO as well as MOEFCC. Many of these networks, for example, if I talk about atmospheric pollutants, MOES has its own network, then there is also a network from ministry as well as from the ISRO's RPNet program. Now, what is required today is that while we have these many networks, as well as there are efforts by individual scientists from various organizations, so we need to create a framework where we can include all of these networks with a think of an interoperable network of networks, so that uniform protocol can be developed, data can be harmonized and accessed. Why this is important? Because there are many, many such observations which are not part of the traditional networks. If we can come up with a harmonized network of networks protocol, any of these observations or measurements that already exist outside the traditional networks can be brought into the whole system. And that will actually lead to, of course, in the process understanding we have been doing, but still today there is an opportunity to use these observations in linkage with the modeling activities and in fact improve them. So that is my first message. It is very important, I think. The second is that already mentioned that there are now innovation in measurement. Now beyond the traditional measurements, for example, if I pick up this example, IIT Bombay has tried to create a hyperlocal forecast where they are measuring rainfall and then trying to sort of forecast at a very, very localized scale using portable sensors. New measurements, for example, we have a network of air pollution, but recently there is an effort to measure air pollution using drones to understand the particle extend to it. Then there are also crowdsourced information, not just in India but globally. All of these innovations are coming. There is also effort. This is an example from US, but similar effort is now done in India. So this is actually an effort in California where scientists tried to use mobile platform with a camera and they measured to develop unprecedented high spatial scale information on air quality. And similarly, as Dr. Ravichandran also mentioned that there are many innovations, using this wiper to get information. Recently, also we tried to, Center for Atmospheric Sciences, find an MOU with Tomato. We are exploring actually if we can use the LiDARs to collect crowdsourced information on basic weather parameters. While all of these efforts are there, we need to standardize this innovation. And this is very important. There is currently a lack of framework how to standardize calibration and measurement protocol for these alternate initiatives. So we need to really, and unless we do that, we cannot bring these new observations into the mainstream network. And this data will be just there standalone and cannot be used even for forecasting and other purposes. So this is also very, very important in my opinion. Then, of course, one of the classic examples is the Rajivan data set, what has been created based on the rainfall observations of century. And I believe that we have a lot of observation and there is an opportunity to develop new products so that these observations applications can be made. There are efforts, of course, for example, there is a global effort to generate very high scale, again you can see 1 kilometer by 1 kilometer data set on maximum and minimum temperature. Now, of course, there is no graded data product at that high spatial scale. The best possible spatial scale information is from reanalysis data, which is roughly around 9 to 10 kilometers. But also we have global point measurements. So what the authors have done is that they have considered the reanalysis data, they have considered the satellite-derived land surface temperature information and used machine learning approaches to generate this information because land surface temperature is not always translated into the true air temperature. And of course, when you create some data product, you need to check the bias and do the bias corrections, which they did using the actual measurements all across the globe. And now there is a data set. You can see it's a very long data set, 2003 to 2020. Daily maximum and minimum air temperature. And this data set has been extensively now used for many other applications. There is now an effort also to generate that kind of high resolution humidity data. But when it comes to heat, we know that temperature and humidity both are equally important. Similarly, in IIT Delhi, we have generated informations about high resolution PM 2.5 data sets. Of course, we have measurements, but they are all scattered. Then we brought satellite information and many other things. And then not just for air quality or for temperature, but there have been efforts from various parts of the academia in collaboration with the government agencies to come up with a range of different data products. And in fact, this type of initiatives are very common in US and other places where projects are given on a mission mode to generate this specialized data to academic institutions. Because of course the mandate for the agencies like IMD and all is quite fixed, and there is an opportunity to really do more. In fact, I was thinking that based on the current observations, where are the opportunities? So the opportunities, for example, we are measuring visibility. Now there is a demand to have a very high spatial scale visibility data, and not just at the surface, but how visibility varies vertically. And then many such information we can harness. Under the able leadership of Dr. Ravichandran and Dr. Mohapatra, already the meteorological services have transformed in a big way. all the efforts are, of course, to provide social security, whether it is health, energy, water, or food. Now, all these new products that I'm talking about require efforts to see what is the demand. And as Krishna also said, that there is demand coming to generate new products at an unprecedentedly high spatial and temporal scale. So when you think of this, we also think that the application is increasing. There are new domains coming where this kind of demand, like risk insurance and many other fields, which are not traditionally using the climate or weather information, but now there is a demand. And when there is a demand, when there is a new technique, it provides new opportunity. We need to really think how we can take these new opportunities and think of designing new products. And then only we can sort of translate all the early warning systems or impact-based forecasting. For example, I work on health, so currently no such framework exists. Yes, IMD is forecasting heat wave, IMD is forecasting, or MOES is forecasting air quality, but forecasting heat wave is one thing, but when you talk about impact-based forecasting, you need to go to different occupational groups, do the health studies in collaboration with epidemiologists and medical practitioners, and then talk about what, let's say, 48-degree temperature means for, let's say, outdoor security guards versus some other occupational hazards. So we are talking about going to that kind of thing. And this is in the shorter time scale. But of course, when you think of longer time scales, again, you need new products to prepare for climate emergency. This is in a longer time scale. Then only we can talk about developing climate resilient infrastructure in the country. This is again, in my opinion, very, very important. We need to really build an ecosystem where we become instrument developer. Now, most of the instruments today that are used for observations are imported. Yes, we have made some efforts to develop the software and hardware parts indigenously, but I think there is a great opportunity to indigenize this whole thing. For air quality, of course, there are some efforts to develop the sensors in-house. Because currently what is happening is that because we mostly import most of the instruments, we are losing a big way. And in my personal opinion, there is also a great economic opportunity. But it cannot happen overnight. We need to create that ecosystem. And it has to start even at a training level. And in fact, what I personally also see that when we talk about any curriculum focusing on weather or climate or any meteorological curriculum should also have a very stronger observational process. It's not like teaching early career scientists or students how to operate an instrument, but much beyond that, whether to more than it means that we need to then collaborate with the engineers so that in next 20 or 30 years we can develop the instruments in-house. That will save a lot of money. And not just that, we create a large market, job creation, and this is completely untapped. And now we are talking actually about these innovations, promoting weather and climate entrepreneurships. And of course, I personally believe that in the next 10 to 15 years, weather and climate entrepreneurship will take a new dimension. My last slide is that, of course, we are all familiar with the grand challenges outlined by World Climate Research Program. If we pick up any of the grand challenges, it requires a strong linkage between observation, modeling, and the impact-based forecasting. And I always think that sky is the limit. In India, weather and climate information is an emerging market, but if you see US and all, it's already a multi-million-dollar. So we need to really take this opportunity, and that can only happen with a ever stronger academia, government, and industry partnership, so that we understand the need of the society. Academia contributes, developing the new products in partnership with the government organizations, and then industry helps us scale it up for practical applications. And of course, that will help us in achieving the path of self-reliance. So I hope that, we think how we can really take this opportunity, transform the way we have been operating and be the provider. Thank you for your attention.
Thank you very much, sir, for starting from the economic perspective and highlighting institutional linkage with the other development in products. Now, I request any question and answer from the audience or online link.
Thank you very much, sir. So it is my privilege to propose the vote of thanks on this special occasion of the World Meteorological Day 2026. At the outset, I express my sincere gratitude to our Secretary, Dr. M. Ravichandran, for presiding over this function and for his inspiring guidance that continues to strengthen our scientific as well as the operational capabilities. I extend my heartfelt thanks to the Director General of Meteorology, Dr. M. Mohapatra, for his visionary leadership and constant engagement and encouragement to the India Meteorological Department. I also convey my deep appreciation to our chief guest, Shri Krishna S. Vatsa, for his valuable insight linking the meteorology with the disaster risk reduction, which is vital for the safeguarding lives as well as the property. And I sincerely thank to our chief speaker, Professor Sagnik Dey, for delivering an enlightenment lecture that enriched our understanding of the atmospheric sciences and the history with respect to the observations. So we are also grateful for the message from the Professor Celeste Saulo, which highlighted the global significance of this year's theme, Observing Today, Protecting Tomorrow. And my sincere thanks to all the dignitaries, speakers, participants for his gracious presence, whether they are online or the offline, for their active engagement. And I would like to also acknowledge the dedicated effort from the organizing team and the support staff, whose hard work ensured the smooth conduct of this program. So with these words, I once again thank you everyone for making this celebration a grand success. Thank you. So now we can go for the group photo outside. After that, the teas. Outside? This outside. Outside. Yeah, sir. I think इधर कर लें I'm speaking.